Very good afternoon. My name is Mushida Arif Bihanafia and I am from Group 1. So we proceed to the calculation analysis as given to us. We need to fix the engine to 4-cylinder with 100 horsepower and 4000 RPM. So we decided to use bore of 93.4 mm and stroke of 86 mm. The first step that we need to take is that we need to calculate the maximum gas pressure. The maximum gas pressure can be calculated by using the formula 10 times the P output. P output is the horsepower, 100 horsepower, equals to average effective pressure time with the VS, the volume of the cylinder, times with number of the speed of the engine times the N over 30 times Z. So the result that we get is that average effective pressure equals to 9.49 bar. Next, proceed to the design crankshaft. When the cramping is at maximum bending moment, we use the formula FP equals to pi over 4 times with bore squares times with average mean pressure. So the FP equals to 65.03 kilonewton.
My name is Muhammad Idham Hamdani and I'm from Group 1 and now I want to tell you about our calculation for when crankshaft is at angle of max twisting moment. First, we're using a formula of sin beta over R equals to sin theta over L, and we must find the beta value. Refer to calculation, we get the beta value is 10.54. That's angle of cranking. And next, we calculate K value equals to FP over cos beta, and we get 66,148 Newton. Next, we calculate the force of tangential with formula Ft equals to K sin 25 plus beta. After we calculate, we get the value 38,453 Newton. For the horizontal tangential reaction, just divided the force tangential by 2 and we get 19,326 Newton. And then for the force radiant, we use formula K cos 25 plus beta, and then we get value for 53,823 Newton. And then for the horizontal reaction radial, just divided by 2 and then we get 26,911 Newton. And then next, we want to calculate of design of crankpin. First, we must find a moment of crankpin. MC equals to HR1 times B2, and B2 size is 93.4 millimeter, and then we get value MC is 251,000 for 564 Newton millimeter. And then we calculate value for the TC tension of crankpin is 826,752.2 Newton millimeter. We calculate radial tension TR equals the square root of MC square plus TC square, and we get value 264,6039.98 Newton millimeter. And for fillet 0.04 D, and we get value 3.736 millimeter. We have value MC before this, and then MC equals to pi over 32 times DC square times stress. And then we must find the DC value, and we get 68.402 millimeter. And then for the LC, length of crankpin, we use formula FP over DC times PB, and it's equals to 95.0737 millimeter. That's it from me. Thank you.
My name is bin Adnan. I'm from Group 1. One part is I'm going to analysis on crank web stress. So formula for crank web stress is M over Z, which is moment over section modulus. So to get moment and section modulus, we need to know the width and the thickness. So by calculation, we get the width 89.65 mm and the thickness is 26.152 mm. To get moment, we use formula HR multiplied by base minus length over 2 minus T over 2. HR is the horizontal reaction, and then by calculating, we get 882,362 Newton millimeter. For section modulus, we use formula WT squared over 6, and by calculating it, we get 10,219 millimeter cube. By using both parameter, moment and section modulus, we can get the stress for the crank web is 86.34517 megapascal. This shows that our stress for crank web is less than stress allowable. Therefore, the design is safe. So now we're going to on the calculation of design on shaft. What we need to find is the bending moment, twisting moment, resultant moment, diameter shaft, and length of the shaft. So we start with bending moment. We use formula FP multiplied by C. FP stands for load on piston and C is the clearance. So by calculation, we get 1.6 million Newton millimeter. For twisting moment, we use formula FP multiplied by R. R is the offset of crank pin, and by calculation we get 2.8 million Newton millimeter. By using bending moment and twisting moment, we can get resultant moment, which is the formula squared BM squared plus TM squared, and we get total of 3.2 million Newton millimeter. On shaft diameter, we use formula cube root of MR multiplied by 32 over pi multiplied by stress crank web, and we get a total of 72.53 millimeter. For the shaft length, we use the formula of FP over dr PB. PB stands for permissible pin pressure. So by calculation, we get 89.66 millimeter for the shaft length. That's all from me. Thank you.
Free benzoyl fluid. To find fatigue of crankshaft pin, we need to use von Mises theorem. That is MEV equals to square root KB times MC squared plus 3 over 4 times KT times TC squared. So we need to use another formula, that is MEV equals to pi over 32 times TC cube times von Mises. Okay, from there we can find the von Mises stress by arranging back the MEV formula. For the torque, we use the formula of KB times MC squared plus KT times TC squared, and then big square root. Next, we need to find shear stress from the TEV. There is another TEV formula, that is TEV equals to pi over 16 times shear stress times D cube. Just substitute the TEV that we get before into the new formula, then we can get the shear stress. We choose high-end crankshaft material, which is the ultra-high strength alloy known as 300M in bracket AMS 6419. This alloy is a modification to the basic chemistry, which added more point to the carbon, so it reached higher achievable hardness and strength, along with 170 points of silicon and 7 points of vanadium. Vanadium acts as a grain refiner, and the silicon enables the material to be tempered to very high strength, that is 285 KSI, and fatigue properties. The material also can be used to manufacture aircraft gears, flat tracks, high strength bolts, airframe parts, drive shaft, and missile components.
Assalamualaikum. My name is Muhammad Ashraf bin Hasanuddin, student ID A147612 from Group 1, and I will be presenting about the crankshaft design, about how do I design the crankshaft, how the crankshaft is made. The table here shows that the specifications that are prerequisite and also obtained from the calculation. The calculation is actually in here, so the draft for the calculation is like this. The one that we would like to be interested in is this, which is the force from the piston is 65 kilonewton. And then here we can see the design of the crank pin. design for the crank pin would be like the diameter for the crank pin is 68.402 millimeter, and also the length will be like 95 millimeter. And also we will note about the crank web where the thickness and the width. The same goes with the shaft where we can see that there is the diameter and also the length. So proceeding on to the SolidWorks, I use SolidWorks to make this. And also the crankshaft is, I designed it to be like this. How do I design it? Let's see in the report. So first, as what I put in the report. So we have considered the diameter for the shaft and also the length for the shaft. And also from this table that I've made, we have created a design for it. This is the shaft, and also it connected to here, 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 the main shaft, and here. And also this is a crank web. How do I design the crank web? It is actually like here. So it says over there that the stroke will be like 86 mm. So we need to put the center from the center of the shaft and also the center of the pin 43, because you know 43 times 2 is 86, right? This one will revolve around, around, and around. And then also the thickness of the crank web will be like 26.15. You can see here also the thickness is 26.15, and also the thickness of the crank pin is 95.07. And I repeated it for four piston, 4 cylinder of pistons, and then it turns out like this nicely. Then I proceed on making a simulation study for it. There it is. I made the place for the bearings, station, fixed. The fix, where it is fixed. Okay, those are the fixed constraint. And also there are force coming up from the piston. So yeah, and the force is like 65 kilonewton. And the result will be like for the von Mises study, here, you can see in here, and also for the displacement, the most is 1.08 E negative 2. And the factor of safety, the minimum is 8 something. So the crankshaft is safe to be used. That's it for the design presentation. Thank you so much. I'm Ashraf, checking out.